What's up, math scholars? Mrs. Hart here for another math lesson. It's a rainy Thursday, but it's okay because we're excited to be learning box method today. Who's excited? All right, they're excited. All right, so I'm not going to make you write down all these steps. That would probably take you a good 20 minutes, but be aware they are saved on my notes. My notes are a PDF file in Polaris. These are all your steps for box method. I think you'll be more effective if I just show you the steps on an example. Okay, so go ahead and write down this example problem. I will go ahead and explain to you why it's going to be the box method rather than the method we've been doing all along. So on your quiz yesterday, you did problems like this. X squared minus 3x plus 2, right? Notice out front, I call this the a value. What is that a value out front? It's a 1. Anytime you have just a normal a value of 1, you can use what I'm now going to refer to as the old-fashioned method of factoring. So you didn't know it yesterday, but you were using the old-fashioned method of factoring. I call it the old-fashioned method because it's the one you learned first, it's the one you love, and it's one that's so easy. You think of the numbers that multiply to 2 that add up to 3. So just for fun, how would I factor this one using the old-fashioned method? Nate? Yeah, a -2 and a -1. So that is called the old-fashioned factor. Yeah. Today, look at our a value. It's a number other than 1. Ooh, when you see a number other than 1 out front, you are going to be utilizing the box method. Okay? So if you have not yet, draw yourself a 2x2 box, and I will explain how this method works. So the very first term, the 2x squared, will get placed in your upper left box. The last number, the -3, will go in your lower right box. I love these problems because it's kind of like solving a puzzle. How many of you have taken biology? Should be every single person because I heard it was a freshman class. Uh-oh, no biology yet? Oh, taking it now. Okay. But basically, this is going to work like a Punnett Square. What we have to do, though, is figure out what will go in these two boxes, and that's what's fun. It's almost like a puzzle. You're going to take that 2, you're going to take the -3, and you're going to multiply them. That would give me a -6. When I get that -6, I actually scribble out this term, and I replace it with that -6. Because now what we need to do is find numbers that will multiply to -6 that would add up to 5. So not very different from what we did in the old-fashioned method. Raise your hand if you know what numbers multiply to -6 that add up to +5. Dan? How about +6 and -1? Does that sound a little better? We need to add up to that +5. All right, so the numbers that you select will go in your last boxes with an X attached to each one. Now you might be wondering, why are we putting X's there? Well, putting X's there so these two diagonal boxes can add up to 5X. Does that make sense? And now we're going to do Punnett Square stuff. So what I do when I do this is I look at this top row, and I pull out a common monomial that would be in common of this box and this box. So basically, what could divide both of these boxes? A 2 and an X. Does that make sense? 2 and 6 are both divisible by 2, and both boxes also share an X. Now at this point I do something called reversing my Punnett Square around, so I just do some thinking. I think to myself, 2x times what up here would be 2x squared, and that'd be an X. Does that make sense? And then I think to myself, 2x times what over here would be a 6x. 3. And then for my second row, an X times what here would be a -1X. -1. And you just want to guarantee that this last box works, you have to check it. Is a -1 times a +3 going to get us that -3? Yeah. So you're done. What you have here on the left side and what you have here on the top will be the contents of your binomials. 2x minus 1 and x with a positive 3. And just like always, if you would like to check, you could just FOIL that out. That would be how you would check it. All right, go ahead and write down the second one. 3x squared plus 20x minus 7. I actually don't know if I mentioned this, but your first step before you do box method should be to just look for a common monomial. Because if there is a common monomial, you want to divide it up to the front. So is there a common monomial in all three terms? Nope. So we're ready to utilize box method. And again, we're using the box because of that 3 up front. All right, so the 3x squared goes in your upper left box. Your negative 7 gets placed in the lower right box. Now don't forget this step. This is the one Dane was asking me about. You're going to take that 3 and you're going to multiply it by the negative 7. That gives you negative 21. What you do with that negative 21 is you scribble out your old last term and you put it in its place. It just makes everything work mathematically. That's the reason for this. 3 times negative 7 is negative 21. So now we get to do some brainstorming. What combinations of numbers will multiply to a negative 21 and add up to a 20? (21 and 1). I agree. Let's go with a positive 21 and a negative 1. Very good with that? So those are going to go in our remaining 2 boxes. Each box getting an X with it. So far, so good. All right, so we're going to look at that top row, the 3x squared and the 21x. What do they both have in common that I could factor up front? I'll erase that to some space. What do these 2 boxes have in common? Like, what's the common monomial of these 2 boxes? 3 and an x. You will always have an x in the top row, and you will always have an x in that first column. It's just kind of how this works. All right, so following it around, 3x times x is 3x squared. 3x times 7 is 21x. And x times negative 1 is negative 1x. And I just checked that this one works. Negative 1 and 7. All right, it works. So let's write what our final answer is. 3x minus 1 and x plus 7. And I could have written those in reverse order. That would have been fine. Beware of the double negative. We've seen double negatives with old-fashioned methods, right? They are tricky. You're going to basically be having numbers that will multiply to yield positives, but yet add up to give you negatives. So it's just tricky. You need to be careful. You need to beware. It's almost Halloween, so like my little witch on here. Go ahead and jot this one down. Beware of the double negative. I can see it right away. It's that positive C term and the negative B term. It's causing the double negative. So before we plop everybody in the boxes, is there any common monomials that could come out first? No. If there would have been, you'd want to do that first, because you never want to do the box method if there's a common monomial in the box. All right, 5x squared in your upper left box. 6 in your lower right box. Now what you gonna do? Multiply them. So that'll be 30. So scribble out my 6. Replace them with that 30. Now you get to do some brainstorming, and beware, there's double negatives. What numbers multiply to a positive 30 but yet would add up to a negative 17? Yep. Negative 15 and negative 2 are our selections. Just make sure you give both those x's, negative 2 and negative 15, both get x's. All right, let's pull out that common monomial in the top row. Unfortunately, I don't think 5 and negative 2 have any common divisors, so I can pull out an x, though. Let's reverse around our Punnett Square. X times what is 5x squared? You can just yell it out. 5. X times what is negative 2x? Negative 2. Oh, I forgot my x. That's probably why I'm getting some weird looks. Alright. Are we okay now? Sorry about that. And then 5x times what out front would multiply to give me a negative 15x. A negative 3. So that's why I'm saying beware. Both of these need to be negative. For this to be a negative, this to be a negative, and for the 6 to be a positive. And it will work. It's negative 3 and negative 2 is positive 6. Good job. That's going to be the hardest type you're going to see, the double negatives. All right, go ahead and jot down this special case. We'll do one special case together, and then we'll get a few rounds of board buddies up here just for some practice. So the minute I looked at this, I was like, ooh, there's only 2 terms. Huh, there's a minus sign in the middle. That reminds me of difference of perfect squares that you had on your quiz yesterday. Remember we had those problems like x squared minus 100, those ones? It reminds us of that, but slightly different. Well, let's think about the common monomial thing. Is there any common monomial we could pull up from? A 2. Yep. And I think 2 is the biggest number you can come up with. So after we pull a 2 out front, watch what's left. 9x squared, that's a perfect square. And negative 25, that's a perfect square. So if you have 2 perfect squares with a minus sign in the middle, you can do that factoring with the same technique we did the other day. You can just square root both these. So the square root of 9x squared is 3x. You'll put a 3x both here and here. And if you square root the 25, you'll get 5. So you can put a 5 here and here. And then lastly, it's very important that one's a plus and one's a minus, so that if we would FOIL this out, our inners and outers would add up to 0. Alright, hello people in the YouTube video. I'm going to send some board buddies up here in class, but maybe at home you could hit pause and try this one by yourself. Hello video people, we're back. I went ahead and did my box. Don't forget you do your 4 times 5 to get that 20. That's an easy step to forget, but if you forget that step you'll be stuck. 10 and 2 is your selected numbers that will multiply to 20 and add to 12. And then you just kind of reverse around your Punnett Square after you pull out that common monomial in your top row. Alright, my next set of board buddies, they're going to do a double negative problem for us. So people at home, go ahead and try this. Heads up, there's a common monomial. Let's do the common monomial together. Before you head to your box, you need to pull out that 3. Nate said it, yep. So after you divide out a 3, you're left with a 4x squared, a negative 8x, and a 3. So every so often, people try to do the box before they pull that monomial out. Sometimes the box works, sometimes it just tanks and it won't work properly. So you have to have that common monomial out first, okay? So try this at home, hit pause, and I'll get some board buddies again. Alright, you can just go ahead and see my answer. We did place that 3 in front of what we got out of the boxes. But the 2x minus 1 and the 2x minus 3 were the binomials that we got from our boxes. You can check that. Alright, this is our last one for our video. It's a special case. My board buddies are actually just about done, so we'll go over it. You didn't even need to pull out a common monomial. You should have recognized right away that 49 and 1 are both perfect squares. So you can use that square root technique. The square root of 49x squared is 7x, so we're going to place that in the first of the slots. The square root of 1 equals 1, so we can put a 1 here and here. And we just need to remember 1 has to be positive and 1 has to be negative, so that if we FOIL this out, our inners and outers would just add up to that 0. Okay? So we're going to be done making our video. I'm going to pass out the homework. It is a worksheet, and it's just like the first part, 1 through 17 odds, but I wrote that on there. Okay? So thanks for watching the video.